In this video, we're going to look at calculating a couple more geometric series using the formula S equals A over 1 minus R. So I should note that these are infinite geometric series. All we need is that common ratio to be less than 1. So a couple ways in which they can be written. So in this one, we go from 0 to infinity of 1 over 3 to the n. Well, that we could, if we wanted to, rewrite as 1/3 to the n. So what that shows us is our common ratio is 1/3. So this one we can do, we need to calculate the first term. Always calculate the first term. Plugging 0 in for n gives us 1/3 to the 0, or 1, over 1 minus 1/3. So 1 over 2/3, flip and multiply, and we get a sum of 3/2. Now this one, if you start to do out terms as written, this is not going to be geometric because you won't see a common ratio. But properties of sums are going to be applied here, because what I can do is I can split this up, 3 to the n over 4 to the n plus 2 over 4 to the n, still an infinite. And now I can split those into two separate summations. So the first one is going to be 3 to the n over 4 to the n, which I can rewrite as 3/4 to the n. That's definitely geometric with a common ratio less than 1, plus infinite sum of 2 over 4 to the n. This is also geometric. 2 is not being raised to the n, but the 4 is. So if I wanted to, I could rewrite that. So the first one we've already said is 3/4 to the n. And both of these are starting at 0. We do want to pay attention to that when we go to sum them. Plus, we could rewrite this one as 2 times 1/4 to the n. These will start at 0 and go up to infinity. So now we're going to apply our formula in each of these. Remember, always calculate your first term. At 0, 3/4 to the 0 is 1. So the first one is going to be 1 over 1 minus our common ratio, which is 3/4, plus, now here the first term, when we put in 0, this becomes 1, but times 2 is actually going to be 2 over 1 minus just the common ratio. Notice there's no 2 in there. That's just a multiple, so the 2 only appears on top. So we're going to have 1 over 1/4 plus 2 over 3/4. That's just doing the subtraction on bottom. We're going to flip both those and multiply. So here we're just going to end up with 4 plus 2 times 4/3, or 8/3. So I have 12/3, finding a common denominator, plus 8/3, for a total of 20/3. So look for that splitting up into two series, and it could be possible this one's to the n too, and so this one would be, and you'd find your common ratio that way. But you'll see this a lot when you're calculating infinite geometric series. You need to split it up into two separate infinite geometric series.